Welcome. Today we're going to look at a new topic. This is topic 2.1, which is entitled Arithmetic Sequences. And as we go through our topic today, remember anytime during the video, if you're unsure of something, pause it, rewind it, and listen to that topic or part again. Sometimes it takes a couple times through to understand it. And also, if you fall behind, pause your video and get your notes caught back up. Okay, let's begin. Our objective today is to express arithmetic sequences found in mathematical and contextual sequences as a function of whole numbers. All right, during this video, remember the skills you're going to need is to listen to comprehend and critically think. All right, let's take a look at our first example. So let's go ahead and switch the slide and go ahead and write this down. It says, given an infinite sequence, and remember, a sequence is just a number or a group of numbers, a set of numbers related by some sort of rule, like a function rule or an equation. Our set of numbers are 5, 10, 15, 20, and 25. So let's go ahead and talk a little bit about words we need to know or some vocabulary. The first thing we need to realize is each number or term, each term in the sequence has a position number. 5 would be our first term. So we're going to name that our position number as n. So I'm going to call these my n's. So this would be in first position, or n is equal to 1. This would be n is 2, n is 3, n is 4, and n is 5. So in the first position, our term is 5. Our second position, our term is 10. Our third position, our term is 15, and so on. So go ahead and make sure you summarize that in your notes. You can pause the video right now and take care of that. Okay, when we talk about the terms, we have to name them as well. So in position 1, our term is 5. We're going to give that the name of A sub 5. Okay, where the A represents the term and the sub represents the position it occurs at. And I just made a mistake, so I'm going to go ahead and erase that. I apologize. Mistakes happen, and that's okay. 5 is in our first position, so this would be A sub 1, where 1 is the position it's in. 10 would be referred to as A sub 2, where it's in position 2. 15 would be A sub 3, and so forth. So this would be A sub 4, A sub 5. All right, and this is an infinite sequence. It means it goes on forever. So we always talk about the nth term, and that's referred to as A sub n. So our ultimate goal is to be able to recognize a pattern and come up with a rule to give us that nth term. Let's just say I wanted the 67th term. I'm going to have a rule for that. All right, so we have our sequence. So the first thing we need to do is let's start looking at it and looking at it and analyzing how are the terms changing. So to do that, it's easier for me if I can just do a table. So instead of x and y, I'm going to have n and a sub n. So my n is 1. It's associated with 5. That means the rule, I plug in a 1, I get a 5. I have 2 associated with 10, 3 with 15, 4 with 20, and 5 with 25. Now, sometimes it's easy to see how the terms change. Sometimes it's not, so we have to learn some techniques. So go ahead and take a look and try to determine how each term is changing. What is it changing by? Pause the video and do that right now, please. Okay, so how are the terms changing? This one is relatively easy to see, but if you're not seeing it, one method to try is find the rate of change or slope. Now you notice my n's, the increments are changing consistently by 1, so my n's go from 1 to 2 to 3. That's important. They're just changing by 1. So I'm just going to subtract the y's. And we're going to call that our first difference. And this is a term we're going to use throughout the course, our first difference. So to do that, I just take 10, subtract it by 5, so larger, or the second number, subtracted by the first. Hey, they change by 5. I'm going to do the second one. or the second group of terms, this would be 15 minus 10. Hey, look, 20 minus 15. And you can see if I do this all the way down, we're going to get the same numbers. So our first difference, or rate of change, is constant at 5. Okay, so we know we're changing by 5. So now our goal is to come up with a rule. All right, so we're going to think of this like a linear equation. If I were to graph this, if I were to come up here and say, instead of x and y, I have n and a sub n, I can see I have a point 1 and 5. So I'm just going to put the points there, 1 and 5, 2 and 10. I'm not going to number my axis lines. But the important part is to see that this is linear. Okay, so when I graph my sequence, it's linear. And we have an equation or a formula, a form we can use to write linear equations. And we're going to use it to find this rule. So to recall, this is our slope-intercept form. We have y is equal to mx plus b, where m is our rate of change or slope, b is our y-intercept, and y is our output value, x is our input value. I'm going to rewrite it as a sub n is equal to, and I'm going to use, let's just use m because it's our slope, n plus b. All right, so I have a sub n is equal to m times n plus b, so I'm just rewriting our linear equation, and I already know my rate of change, my slope is 5, so I'm going to go ahead and substitute that in. I also am going to have to require points, so n and a sub n, I'm just going to choose the easiest one. For me would be 1 and 5. So 5 is our a sub n would be 1. So just as we wrote the linear equation, we can do the same to write the rule, because again it is linear, so I'm doing some quick simplification. 5 times 1 is 5. Solve for b by subtracting 5. And we can see our b is equal to 0. This implies our rule, and it's going to be in the form of a linear equation, would be a sub n is equal to our slope, which is 5, times not x, but n, because n is our input in this case, and our b is 0. We don't have to worry about it. That is our rule. Now we can test our rule simply by plugging in term numbers. I can plug in values for position in the sequence to get the value of the term sitting in that position. So I mentioned 67th term, I believe, earlier. I'm not going to do 67. I'm going to do 60. So if I wanted the 60th term, I could say, what is n at 60? Well, I could plug that into my rule, and let me kind of space it out just a little better before I go any further. I'm going to find that 60th term. I'm going to go ahead and get my pen back. And I just have a little bit of room. We'll just box it off like that. What is n at 60? Well, that would be a at our 60th term, which would be, this case, plug in a 60 at n, which would be our a at 60 would be 300. Okay, as we wrap up the video, remember, walk away, summarize how we found the rule, make note of that it can be graphed, how this sequence fit a linear style, and make note of the first difference and how we found that rate of change. We're going to need this video as we continue through the slides. If you have any questions, please write them down or ask me in class. Thank you.